Alright, so we're going to talk about classifying functions as either linear, quadratic, cubic, exponential, absolute value, or square root functions. There are these different types of functions, and it's important that we can look at the function and decide which type it is. Now, if you have the function in equation form, sometimes you can tell. For example, if there is a square root, then you know that it's a square root function. If there's like an x squared, then you can assume if that's the highest exponent in it, the 2, then it's a quadratic. So sometimes you can tell an equation form. If you can't, then you should graph it and match it to the shape that it fits best. If you have a table of values, if your function is in a table form, then you should plot the points on your calculator and then look at the graph to see which form it most closely matches. If you have a graph, then you can look at that graph and decide which shape it matches most closely right from that graph. So let's look at the different shapes. The first one we're going to look at is linear. Now, each of these 3 examples are of linear functions. Notice that they can be slanted, or we can call that oblique. They can be vertical lines, or they can be horizontal lines. But you just want to make sure that the slope is the same. There's no curves in it. It's a straight line the whole way. A linear function often looks like that. Or for example, with numbers, it could look like that. That could be an example of a linear function in equation form. The next one we're going to look at is quadratic. Now the main equation for quadratic would be, we'll use f of x here, function notation, since it's a function. F of x equals x squared. We can change this one to f of x also, instead of y. So f of x equals x squared. Now, whenever the highest exponent is a 2, the squared, that means that it's going to be a quadratic function. Quadratic functions look like U's. Notice that they can either face up, or they can face down, or they can be skinny, or they can be wide, or they can be right in the middle of the graph, so it like kind of goes out from the y-axis in both directions, or it can be moved. Lots of different variations, but the quadratic function will always look like a U. Now, it goes up and out forever and ever in both directions. That's important to know. Now, the way that you move it is you add different things to this x squared. You can make it 2x squared or 2x squared plus 4. But regardless, if this is the highest exponent, the 2, it's going to be quadratic. Now let's look at cubic functions. Cubic functions occur when the highest exponent is not a 2, but a 3. So f of x equals x to the 3rd power, or x cubed. Notice with these, it starts going one way, to the left it either goes up or down, and then to the right it goes the opposite way. Here it goes down to the left and up to the right with some curving in the middle. Here it starts going up, but to the right it's going down with some curving in the middle. And then same thing over here. It starts up, ends down with some curving in the middle. With a cubic function, it doesn't, either way it could start up and go down, or it could start down and go up. And it can only curve a maximum of twice, because it can only hit the x-axis 3 times. if it's a cubic function. If it hits more than that, it might be a higher power up here. Next, let's look at exponential functions. Exponential functions means that in the equation, here's an example, we'll say 3 to the x power, the x is the exponent. That's why it's called exponential. Now with exponential functions, they can either to the left or to the right get closer and closer and closer to the x-axis, but never actually touch it. They will never cross this line, the x-axis. And then in the other direction, it goes up and out for forever. So here, to the left, it's getting closer and closer to the x-axis. To the right, it's going up and out forever. Here, to the left, it's going up and out forever. To the right, it's getting closer and closer to the x-axis. These are all variations of exponential function graphs. The important thing, though, is that whenever the x is in the exponent, it's going to give you a graph similar to this. It will be exponential. Next is absolute value graphs. Absolute value graphs look like these. And the absolute value symbol is like two lines on either side of the x. Now if you have these two lines, kind of like parentheses, but these mean a little bit more than parentheses, your graph is going to end up looking like a V. The V could face up, it could face down, it could be skinnier, it could be wider. There's lots of different options for your V, but if it's a V, that means it's an actual point right there. It's not a curve. It's a point. If it's a V like that, it's an absolute value function. These two lines in equation form are a good tip-off that it's going to be an absolute value function. Lastly, we'll look at square root functions. Now this is an equation or a function that has the square root of x in it. Square root functions have a specific starting spot on the graph. This could be at the origin or it could be shifted off the origin. And then it goes up and out forever from that point. So that is a basic rundown of the 6 different functions that you will have to be able to recognize and classify in this class. At the beginning, we're really just trying to look at these graphs and just being able to match which name, which function type goes with which graph.